Technology Delhi. I am pleased to welcome Dr. Rinkle Rani, who is here today to share his knowledge on big data and its application in healthcare. Dr. Rinkle Rani is currently working as a professor in the Department of Computer Science and Engineering, Thapar Institute of Engineering and Technology, Patiala. She obtained her B.Tech with distinction from the PTU Jalandhar and MS from BITS Pilani. She received her PhD degree from Punjab University, Patiala in 2011. She has more than 27 years of experience in teaching. She has over 202 research papers, of which 106 are in international journals and 96 are in conferences. She has guided 14 PhD and 52 ME theses. Her areas of interest are big data analytics and machine learning. She is a member of professional bodies ACM, IEEE, and CSI. Ma'am, over to you.
Okay, thank you. Sure. Let me share my screen first.
It's visible, ma'am.
Yeah, thank you. Is it working now? The slides are moving.
No, ma'am, I can see only the first slide right now.
The second slide is not. I am on the second slide, third slide. No.
We are not able to see the full screen of
Okay.
slides. Yeah.
Ma'am, it is not onto the slideshow mode.
Ma'am, I have made it on the slideshow mode and I am scrolling the slides. Just
Ma'am,
want to know.
ma'am, I guess you shared a window. I guess if in case you share the whole screen, I guess then only they'll be moving.
Okay, let me share again. Let me share again. Still, it is showing window. Is it visible now, ma'am? Or not?
No, ma'am, not yet.
Yes, ma'am. I think.
Let me check again. Just wait. Ma'am, is it visible now?
Yes, ma'am, slides are visible.
Okay. Is it scrolling?
Yes, ma'am, it's scrolling. You can continue, ma'am.
Thank you.
Ma'am, but it is
Yeah.
still not onto the slideshow mode.
Now it is slideshow mode, ma'am. I have done it.
No, ma'am. Actually, right now we are only able to see first slide only.
I am moving the slide. एक minute. And show I have done.
Ma'am, please use F5 in case.
Yeah, sir, I am doing that also. Like if this is the screen mode, now are you able to see the second slide or not?
Yes, yes, we are able to see the second slide.
But when I use slideshow, it is not visible to you. I'm not able to understand. Again, I am doing slideshow. Now is it visible?
No, ma'am, no.
It is visible,
Ma'am,
ma'am.
ma'am, the slideshow mode is not visible. Because can you help ma'am while ma'am is sharing the screen? I guess ma'am is sharing a single video or something.
The whole of the screen I have shared, actually.
Ma'am, please use this button which is available just on the bottom right corner of the window, near 60%. There is a button. I think this will help us.
This
Yes.
one,
No, no, the third one. The third one.
slideshow.
Yes, yes, this one, ma'am.
Is it visible now?
No, ma'am. Current, it didn't work actually for us.
No, because the problem is not that. Problem is when ma'am is joining. So ma'am has to unshare the screen, and while ma'am is joining at that particular moment, ma'am is saying that ma'am is still joining it into the complete screen. But I guess the problem is from there only. Problem is not from once she has joined us. She has shared the screen. So while sharing the screen, there is some problem.
Uh, Let me share again, ma'am. Just give me a few minutes.
Ma'am, uh, please
It's
use the
saying,
entire screen option, ma'am. After pressing the share button.
yes, share button. It is saying presenter mode.
After pressing the share button, ma'am, it will give you the options share content, screen window or tab. Please choose
It is
that.
showing
And
only screen and two windows me.
yes, ma'am. Now, when the pop-up for choose what to share with teams will come, there will be three options. One is for your
No, there
browser,
is
second
no
one is for
pop-up, sir.
Windows.
There is no pop-up. Let me check. I'm not able to
Ma'am,
do
as
this.
soon as you'll click onto the share button, as soon as you'll click on the top, you'll get three things: Microsoft Edge tab or whatsoever Google Chrome you are using, then window, then entire screen. So
I mean,
whenever
entire screen, there is no option for entire screen. It is showing only two windows to me.
Okay, okay. Ma'am, I think I will be able to help you, I think, on any desk if it is possible for you.
ma'am, do you have any desk onto your system on your
No,
laptop?
no, ma'am.
Shelly ma'am, I think मैम आप मुझे मैम का नंबर शेयर करें तो I think we can communicate. I mean, it will resolve us.
ठीक है विकास, मैं मैम का नंबर शेयर कर दूं आपके साथ.
Sure, ma'am.
Sir, is it working now?
Yes, ma'am, it's working now and
Yes, ma'am.
slides are changing.
Slides are changing.
Yes,
Yes, ma'am.
and it's on slideshow mode. Perfect.
Okay, should I start?
Yes, ma'am, please,
So,
ma'am. Please.
yeah, good afternoon, everyone. Sorry for the inconvenience caused. Yeah, the topic of my today's presentation is machine learning is in healthcare. So, features, applications, and opportunities. The outline for my today's presentation is first is introduction to healthcare. After that, I'll give a brief overview of benefits and applications of healthcare, followed by success stories of few of the ML based software platforms. Then we will discuss how machine learning works in the area of healthcare. Then key machine learning techniques in healthcare, latest research trends in machine learning for healthcare. And in the last, I'll be discussing emerging technologies and few of my research contributions in the area of machine learning and healthcare. So let us start with an introduction to the healthcare. Healthcare is an industry that is constantly evolving. New technologies and treatments are being developed all the time, which can make it difficult for the healthcare professionals to keep it up. So therefore, in recent years, machine learning in healthcare has become one of the most popular buzzwords. But before learning how healthcare industry is using machine learning, we must know what is machine learning exactly in the field of healthcare. Why is machine learning so important for the patient data? And what are some of the benefits of machine learning in the field of healthcare? What is machine learning? Machine learning is a specific type of artificial intelligence that allows systems to learn from data and detect patterns without much human intervention. This machine learning in healthcare is used to draw insights from large medical data sets in order to facilitate clinicians' decision making, improve patient outcomes, automate healthcare professionals' daily workflows in order to accelerate medical research and increase the operational efficiency of the hospital staff. In nutshell, we can say that the significance of machine learning in healthcare is to revolutionize the diagnosis, treatment, and patient management. Or you can say these are the three main focus areas of healthcare where machine learning is being used: diagnosis, treatment, and the patient management. Now, next is the key features of machine learning in healthcare. You can say how machine learning is helpful in the area of healthcare. First is data-driven approach. Whenever we use machine learning for healthcare services, we can utilize a large amount of healthcare data, which is used by the machine learning models. Second is predictive analytics. For in order to make prediction, detection from the patient data, again, machine learning is very helpful. Real-time processing. Actually, what happens when we are using sensors, say in the form of body area networks, then we are collecting continuous data for the patients. And then on the basis of that data, machine learning models can provide decisions, or you can say on the spot decisions. Next is automation. Automation, we can automate the whole of the process of storing, managing, querying, and providing services to the healthcare. In the last, it is scalability. Scalability means when we are handling large amount of data, you can say a very big amount of data for the healthcare industry. In that case also, machine learning is very helpful in order to analyze that data. So next we will discuss what are the main benefits of machine learning in the area of healthcare. The first benefit is automated routine tasks. So here we can say that by streamlining EHR processes and providing virtual nursing, machine learning can help healthcare professionals to automate many routine and repeatable tasks, and thus it will be reducing the operational cost. Second, it is providing improved decision making. So here, by detecting patterns in enormous healthcare data sets, machine learning helps clinicians to streamline diagnostics and improve decision making. Therefore, we can say that it will be enhancing the patient outcomes. Third one is enhanced patient experience. Uh, with the help of, say, chatbots, virtual assistants, these healthcare organizations can improve the patient experience by streamlining access to the basic healthcare services. So, next is accelerated innovation. By optimizing drug discovery and development, machine learning can help pharmaceutical companies to reduce time to market and the research cost. Extended access to healthcare. Here we can simply say that with the efficiencies which are unlocked by machine learning, organizations can help more or maximum number of patients without compromising with the healthcare quality. Then it is reduced risk. So machine learning adoption allows for early detection of serious illness, therefore reduce risk during robotic surgeries and quick identification of high risk patients. Redefined data governance. So, machine learning algorithms can help healthcare organizations to identify inconsistencies within disparate healthcare datasets, cleanse data, and validate its integrity. Therefore, the government policies are well defined and are used by the machine learning models. So next we have applications of machine learning in healthcare. The very important or the most important application is the medical imaging. In the field of medical imaging, machine learning can help in the early detection of diseases using MRI images, CT scans, and X-rays. For example, cancer detection, fracture identification, etc. The second application is drug discovery and development. Here, ML can help by predicting drug efficacy and its side effects. Third application is personalized medicine. So here, machine learning can tailoring treatments based upon individual genetic profiles. Fourth one is predictive analytics. Predictive analytics means machine learning can analyze the data sets by training and testing and can predict disease outbreaks for patients. So thus it may helpful in guiding readmission of the any patient in the hospital. Next is virtual health assistants. So AI chatbots for the primary diagnosis and patient interaction are very helpful, where again machine learning is contributing a lot. In the last, we have chronic disease management. Machine learning can monitoring conditions like diabetes and heart diseases, and these monitoring conditions will be helpful for the further medication and decision making. Now I will discuss some of the machine learning based software platforms that have been designed by various um, um, companies, software companies, which are very helpful and are used by the healthcare industries as well as by the researchers. The very first one is Google's DeepMind. What is DeepMind? DeepMind is an AI research lab which was acquired by Google in 2014. The main focus of this DeepMind lab is on building general purpose artificial intelligence based systems which are capable of learning and solving various problems in healthcare. So there are many contributions which are made by the DeepMind lab. The very first contribution or major contribution is in the field of medical imaging. For this DeepMind lab partnered with NHS in order to use artificial intelligence for the detection of eye diseases from retinal scans. And with the help of machine learning and artificial intelligence, DeepMind achieved 94% accuracy in detecting diabetic retinopathy. And the second contribution of DeepMind is protein structure prediction. Here, they designed a software with the name of AlphaFold. So AlphaFold basically contributed biology by solving the decades-old challenge of protein folding. AlphaFold predicts protein structures with atomic level accuracy, and it enables faster drug discovery. And the third contribution from DeepMind is the diagnosis and treatment, that is predicting acute kidney injury 48 hours before clinical symptoms, and enhancing diagnosis of cancers through AI powered analysis. These three are the main contribution which are made by the Google's DeepMind Health Lab. So next is IBM Watson Health. So Watson Health is basically AI suite. It is a software which is a combination of AI and machine learning tools which are designed specifically for healthcare and life sciences. So this suite uses deep learning and predictive analytics to process structured and unstructured healthcare data such as medical records, images, etc. There are various applications of this IBM Watson Health. The first is oncology treatment. Watson for Oncology analyzes cancer patient data in order to recommend personalized treatment plans. The second application is drug discovery and research. So it speeds up the drug discovery by analyzing complex biological and chemical data. Third application is clinical decision support. It provides doctors with AI-driven recommendations for the diagnosis and treatment. Then patient management. It improves the patient care by identifying at-risk individuals and thus optimizing the hospital workflows. The last application is chronic disease management. So this software predicts complications for diseases like diabetes, heart disease, and kidney failure. So these are the main applications of the IBM Watson healthcare suite. So third one is Path AI. So this Path AI is an AI powered platform. It also uses advanced machine learning algorithms in order to assist pathologists in analyzing medical images. For example, tissue samples, slides, etc. etc. So this Path AI was founded to reduce diagnostic errors in order to improve treatment outcomes and thus to assist in drug discovery and clinical trials. Path AI is an independent company. It was founded by Dr. Andy Bake and Aditya Khosla in 2016. It is not designed or owned by another company, but it has partnerships with leading pharmaceutical firms, biotechnology companies, and healthcare providers to advance pathology workflows using AI. There are certain main applications of AI, Path AI. First one is cancer diagnosis. AI powered tools here improve the detection and classification of cancers such as breast cancer and prostate cancer. It reduces diagnostic variability among the pathologists. Second application is biomarker discovery. Path AI helps to identify biomarkers for diseases to improve early detection and targeted therapies. Third is drug development. It supports pharmaceutical companies in analyzing clinical trial issue samples, enabling faster drug approval timelines. Then it has quality assurance in pathology. It ensures consistent and high quality pathology analysis across various laboratories. So these three are the ML-based software platforms which we have discussed and have achieved accuracy, very high accuracy, we can say. So next, we will discuss how machine learning works in the area of healthcare. So the very first focus is on data collection, second data pre-processing, then we have model selection, and then the evaluation. Basically, whatever modeling or research we are doing in machine learning, we need to follow these 4 steps. In the first step, we are supposed to collect data. So this data sources can be the electronic health records. It can be the medical images, maybe MRI images, X-rays, etc. We can have wearable devices in the form of sensors. We are collecting data for the patients, and it can be in the form of clinical trials. We are having medical reports, and from which we can assess the features of any patient. So after the data collection, the second step will be data pre-processing. Whatever data we have collected from these heterogeneous resources, that data may not be in a adequate or suitable for the modeling. So we need to pre-process that data. Pre-processing usually includes handling missing values, or it may be there may be requirement of normalization, and there may also be requirement of data security. Depending upon the requirement of your application, we need to pre-process our data sets. So after that, the third step is the model selection. For model selection, we need to use various machine learning algorithms. Depending upon the data sets, we have to use clustering, classification, ensembling, and various large number of algorithms as per our requirement. Once we have selected the model is trained for the given data set, and it will be tested for the unknown data set, and we can evaluate the performance of the designed model on the basis of various performance metrics in the fourth step, on the basis of accuracy, precision, recall, F1 score, etc., etc. So these are the 4 main steps while providing services to healthcare using machine learning. So now I'll discuss key machine learning techniques in the field of healthcare, or what researchers are using to provide service in the field of healthcare. So the very first technique or important technique is supervised learning. What is supervised learning? Supervised learning is a type of machine learning where the model is trained on a labeled data set. In this approach, the data set contains both the input data, which we say are features, and the corresponding output labels, which we say are the target values. The model learns to map these inputs to the correct outputs by identifying patterns in the given data set. So there are basically two types of supervised learning. First is classification. The goal of classification is to predict a discrete label or category. For example, we can check whether the email is a spam or not. So there are only two possibilities. The mail can be a spam mail or it cannot be a spam mail. Second example is disease diagnosis. Like the medical report can be simply positive or negative for a given condition. Third example can be image classification. On the basis of given image, we need to check or detect whether the image is of a dog, cat, or a bird. So these are a few examples of the classification. The second type of supervised learning is regression. The main goal of regression is to predict a continuous numerical value. For example, predicting house prices, estimating a patient's blood pressure, forecasting, you can say, stock prices, etc. So how this supervised learning works? If we see, first of all, we have the input data, which we are saying is a labeled data. So this labeled data set is split into training data and the test data. So second is model training. This model uses the training data to learn relationships between the inputs and the outputs. So algorithms we can use like linear regression, decision trees, neural networks, etc., etc. But the major algorithms which are used for supervised learning are linear regression, which we have to use for simple regression. Then we have logistic regression, which is specifically used for binary classification. We have support vector machines, decision trees, random forest, then the k nearest neighbors, that is called KNN algorithms, and we can also use neural networks. Then the next phase is prediction. So once the model is trained, the model predicts outputs for the new and the unseen data sets. That is called test data. So in the last part, we have the evaluation. We can check the performance of the proposed model on the basis of the metrics. The metrics we have discussed can be accuracy, precision, and others. So this is the basic diagram, how the supervised learning works. Next, we have unsupervised learning. Unsupervised learning is a type of machine learning where the algorithm is trained on data without labeled outputs. Here, the goal is to uncover hidden patterns, structures, or relationships in the data. If we say, unlike supervised learning, there are no explicit output labels or target variables in case of unsupervised learning. There are mainly three types of unsupervised learning. First is clustering. Clustering means group similar data points into cluster based upon their features, or you can say data points which are having same set of features or have similar features will be placed into one cluster. For example, customer segmentation. Customer segmentation means grouping of customer on the basis of their purchasing behavior. Second can be identifying types of diseases based upon symptoms. So second type of unsupervised learning is dimensionality reduction. So it reduces the number of features while preserving the important information. So the main techniques which are used for dimensionality reduction are principal component analysis, T-distributive stochastic neighbor embeddings, that is called TSNE technique, and autoencoders, which are used in neural networks. And the third type of unsupervised learning is association. It identifies relationships or rules in the data. For example, market basket analysis to find items which are frequently purchased together. For example, butter and bread. These two are the things normally people purchase together. So in the diagram, we can see that in unsupervised learning, we have raw input data, but they are not labeled. So after applying machine learning models, we are placing the similar similar data items in one cluster. So we are having 3 different clusters where we have placed the given input data items. And next is reinforcement learning. This is a third type of machine learning, where an agent learns how to make decisions by interacting with an environment. Here, the agent goal is to maximize cumulative rewards over time by taking the most appropriate actions in different states of the environment. Here the basic need is the current scenario or the environment that has to be considered for the decision making. So the main applications of this reinforcement learning are robotics, gaming, autonomous vehicles, and industrial automation. And the last type of machine learning is deep learning. Basically, this deep learning is a subset of machine learning and AI. It focuses on using neural networks with multiple layers. Hence, we use the term deep because we have a multiple layers models. In order to model and understand complex patterns in data, multiple layers are used. It is particularly well suited for tasks which involve large data sets, means large data, we can simply say big data we have, and unstructured data such as images, audios, and text. What are the main advantages of deep learning? Why researchers are using deep learning nowadays in healthcare? Because it handles complex and high dimensional data very easily. It reduces the need for manual feature extraction. In case of supervised as well as unsupervised learning, we have to extract features, because if we have a very large number of features, we have to use feature extraction techniques ourselves. But if we are using deep learning, there is no need to use any feature extraction technique. It will be automatically used by your deep learning model. So it continues to improve as data size and computational power increase. But for the implementation of deep learning models, we need to face certain challenges also. It requires significant computational resources, needs large amounts of labeled data for supervised tasks, and there will be a risk of overfitting if the model is too complex for your data set. So these are the certain advantages and challenges in the use of deep learning. So next is research trends in machine learning for the healthcare. So now I will discuss few of the latest research trends, or you can say the areas where the researchers are working. Very first thing is explainable AI, that is XAI. Basically, this XAI is a set of techniques and processes that help people to understand and trust the results of AI and machine learning algorithms. Here, the main word is trust. algorithms which we are using for machine learning. The main aim of XAI is to make AI systems more transparent and understandable to the humans. And therefore, it will be bridging the gap in between the complexity of AI model and the human understanding. There are various approaches which are being used for the implementation of XAI by the researchers. The most commonly used approaches are LIME, SHAP, and EL15. What is LIME? A LIME is a technique that can be implemented in Python using the LIME package. Second is SHAP. SHAP is a technique that uses the Shapley value from game theory to provide insights into the most influential factors in which we have used in the prediction of the model. And the third example is EL15. EL15 is a technique that uses simple language to provide insights into the most influential factors in the model predictions. Is the factors which are most influential while making predictions from the model. So these three are the basic examples which the researchers are using for the XAI. The most use is with the line because it is simply available in the Python library. So the second research area is nowadays federated learning. What is federated learning? Federated learning is a machine learning technique that trains model on data from multiple devices without sharing the raw data. Actually, in case of federated learning, each device shares its local parameters instead of the entire data set which it is using for the training. However, the aggregator node receives the model parameters and trains the global model, which then it broadcasts to all the clients. The main benefits of the federated learning are it can enhance the data privacy as well as the security. It can meet the you can say latency requirements. And the major feature is that it can update parameters in a distributed manners. The example of federated learning tool is TFF that has been designed by Google, and the name is TensorFlow Federated. We can use this tool, that is TFF, for the implementation of federated learning while we are using the machine learning algorithm. Machine learning algorithms, we are limited to only one device, but if we need to use data from different devices, we can use the concept of the federated learning. And the third area is synthetic data generation, which is also being used by the researcher in healthcare, or you can say in the machine learning area also. What is the need of synthetic data generation? Actually, what happens when we are working in the field of healthcare, sometimes we are not having data, the sufficient amount of data for the training and testing of your model. In that case, we are supposed to generate some data synthetically. Earlier, when the data was structured, we use simply random functions. But nowadays, we have to deal with the unstructured data. For that, we use the concept of GANs. So these GANs are called generative adversarial networks. So it generates artificial data that mimics the characteristics of the original data set. This synthetic data, which is generated by the GANs, will be similar to the data which we already have. So the total amount of data for the training and testing will be increased. And the fourth area is transfer learning. What is transfer learning? Transfer learning is basically a machine learning technique that uses knowledge gained from one task to improve performance of the related task. Or you can uh, uh, say one example, a model that can identify dogs can also be trained to identify cats by using a smaller image set that highlights the difference in between the two. So basically what we are doing in case of transfer learning as a researcher, we are using pre-trained model for the another data set. The model which we have trained for the one kind of data set can be reused for the different second type of data set. Okay, so basically these transfer learning techniques are used by mostly deep learning models. So there are pre-trained deep learning models which are being used by the researchers. They are using few layers of these pre-trained model and thus avoiding the complexity of the new model. So next we will discuss the emerging technologies in the field of healthcare. So we can see from the diagram, we have combinations of AI and ML, we can say. First technology is AI and ML. Second can be cloud computing. Third is here blockchain. And then we have Internet of Things. These four are the emerging areas or technologies which are providing services to the healthcare. Or you can say these are the research areas for the academicians and the researchers. So we have discussed few points about the machine learning and AI. Now we will see how we can combine this machine learning with the other these three areas to provide better services and get the better research outputs in the area of healthcare. So first is cloud computing. What is the use of cloud computing in healthcare? Simply, what is the usage of this cloud computing? The very important or the most important is the data storage and management. So here we can say that cloud computing provides scalable and secure storage for vast amount of healthcare data, which may include your EHR, which are called electronic health records, images, and genomic data. It ensures data accessibility from any location by the authorized users. Once you have stored data on the cloud that is accessible at any location, okay, simply we can access the data, whatever data is required. Second application or the use is interoperability. So, by enabling seamless sharing of medical data among the healthcare providers, researchers, and patients, we can provide interoperability. Like the same data set which we have uploaded on the cloud can be shared by multiple hospitals. The same data set can be used by the researcher. Okay, so it is used by anybody on request, provided we are authorized to use that data set. So basically here the concept of blockchain, cloud computing combinations will be used. I will discuss later. And third thing is big data analytics. So processing and analyzing large data sets to derive insights for say disease trends, patient outcomes, and operational efficiency. So whatever data is stored on the cloud, obviously the data will be big. So the data analytics is supported by cloud computing. The fourth point is telemedicine and remote monitoring. So by supporting, you can say virtual consultations, remote monitoring of patients through cloud hosted applications, we can provide the services, or you can say cloud computing can provide the services. The another thing is by storing and analyzing real-time data from wearable devices, the analysis will be more easier. Because if we are having wearable devices with the patients, then the data will be generated continuously, or you can say a large amount of data will be generated. For the storage of that data, we have to use cloud services. It is not possible to store these census data on a simple machine, because when once the data is uploaded on a cloud, we can use it for the analysis for further decision making. Next point is cost efficiency. By reducing the need for physical infrastructure for data storage, processing, so there will be cost saving for the healthcare providers. So next use is artificial intelligence integration. So by hosting machine learning models in the cloud for tasks such as image recognition, predictive analytics, and natural language processing, we are basically integrating AI and cloud computing. And then we have disaster recovery. So by ensuring healthcare data is backed up and recoverable in case of natural disasters or cyber attacks, we can ensure disaster recovery. So these are the few uses of cloud computing in the field of healthcare. So next is, what is the combined impact of integration of ML with cloud computing? So if what will be the combined impact or the useness of this ML and cloud computing? First thing is, ML models which are hosted on the cloud, they can process vast healthcare data sets more efficiently. Second is, real-time analytics and predictions can be delivered globally, facilitating faster and better informed decisions. And the third advantage can be scalable solutions for personalized medicine, telemedicine, and public health management is also possible. So, this synergy is basically revolutionizing the healthcare, enhancing patient outcomes, and thus enabling more proactive and data driven decision making. So next is blockchain technology. So we know blockchain technology is used for data security. So I'll discuss few uses of the blockchain technology when it is used in healthcare. The first is data security and privacy. This blockchain technology provides tamper-proof storage for sensitive healthcare data. We can say tamper-proof storage is sensitive. The data is sensitive because we have personal medical data and reports of any patient which is not freely available to anybody. In case of blockchain, only authorized users, where we use the concept of encryption, decryption also, only by authorizing the particular hospital or third party, the data will be available. So it ensures compliances with the regulations like HIPAA and GDPR also. The second advantage is here interoperability. So it facilitates secure and seamless sharing of patient data among the healthcare providers. So the if say one patient is having treatment from the one hospital at a time, but for the second opinion he wants to visit the another hospital, then there is no need to carry a physical file with so many reports and papers, you can say. In that case, whatever data he has already on the blockchain, he has to simply authorize the second hospital as well as the doctor from that hospital for the data sharing. In that case, simply the data will be transferred, or you can say shared with the second hospital. So that is the main advantage of the blockchain technology, that only the authorized you can say parties can share the data. So it improves data integration across EHR system and the research platforms. The third use is patient data ownership. As I have told you, empowering patients to control access to their health records through the smart contracts. In case of blockchain, we use the concept of smart contracts. Smart contracts are basically small functions, um, like we write functions in C, C++, and other languages, also programming languages. In case of blockchain technology, we write some code in the form of, say, smart contracts, which are actually functions. And with the help of these functions, we can provide control to the other third parties. So it enhances the transparency in the data usage also. Next use is supply chain management. Here we can say that by tracking pharmaceuticals and medical equipment, we can prevent the counterfeit of drugs. Uh, by ensuring the integrity of supply chain for vaccines and medications, the overall healthcare services can be improved. Then it is clinical trials and research. Storing trial data securely to maintain integrity, you can say, and prevent manipulations, we can use blockchains. So then we have claims management. Claims management means we have the persons which are having insurance and other things. So it may, if we are using here blockchain in healthcare, then it may automate the insurance claim processing with the help of blockchain and reduce frauds and errors which are related to the insurance policies. So now we will discuss the combination of machine learning and blockchain together, how it will be helpful to the healthcare industry. So the very first is enhanced security. So it will protect sensitive healthcare data during analysis and the transmission. Second benefit can be improved accuracy. The machine learning models which are trained on verified blockchain data obviously will be reducing the errors in the overall system. Third advantage can be transparency. Blockchain, we know it always ensures data provenance, building trust among the stakeholders, because there will be transparencies in the data, what is being stored on the blockchain as well as in the cloud, whatever we are using here. The fourth one is efficiency. Machine learning automates the processes while blockchain ensures compliance and auditability. So thus the overall system will be more efficient. Therefore, we can say that by integrating these two technologies, healthcare systems can achieve more secure, efficient, and personalized patient care. So the next is we have Internet of Things and machine learning combinations. So I have told you in the previous slides also that if we have to use sensors, basically Internet of Things and body area networks, we can collect large amount of data. Obviously, that data we have to use for training and testing of the machine learning models. Okay, so let us see when we are combining these Internet of Things and machine learning in healthcare, how useful it can be. So when this machine learning and Internet of Things are used together, their synergy enhances healthcare outcomes significantly. Okay. So the first can be the real-time health monitoring with predictive analytics. Whatever data we are collecting, so that is called streaming data, continuously data we are generating and collecting and analyzing. Second can be the chronic disease management. Chronic diseases like we are measuring like diabetes, we are measuring the BP, and as and when there is some beep, or you can say the value increases or decreases the threshold value, there should be, we can say, a beep is there, so we can make the decisions accordingly for these chronic diseases. Telemedicines and virtual care. So this Internet of Things devices transmit patient data to the doctors during the virtual consultations. So then we can have smart alarms and alerts. So again, we are monitoring. We can send messages, some alerts to the patient also, to the doctor also, so that immediate help can be provided. And the next we have resource optimization. Obviously, this IoT also tracks hospital equipment usage. However, this machine learning can predict maintenance needs and allocates resource more efficiently. So ultimately, we can have resource optimization with the combined use of IoT and the machine learning. In the last, it is infection control. So this Internet of Things monitor environmental conditions in hospital, like we can monitor the air quality. So this machine learning model can predict and mitigate the spread of hospital acquired infections. This whatever data we are getting, we can say what kind of infections are there in the environment of the hospitals. The main thing is data collection and data analysis. Data we are collecting from IoT devices and analyzing using machine learning. So that's all about the main things about the machine learning, AI, emerging areas, and so on. So now I'll discuss some of my research contribution in the field of healthcare where we have used machine learning. So the disease which we have taken for our research work is basically neurodegenerative diseases. What are these neurodegenerative or which are called cognitive diseases? It refers to the disorders in which degeneration of neurons occur that impairs the normal functioning of the central and peripheral nervous system. So there are basically many neurodegenerative diseases which are used as a data set by many researchers which are working in the area of machine learning. But for our research work, we have used dementia. We have used dementia as the main disease for machine learning. What is dementia? So dementia is basically an intensive find condition having hallmarks such as memory loss and disturbances in one or more cognitive domains. So the patient which is having the problem of dementia may be having the problems in the form of language, motor skills, recognition, and day-to-day functional activities. If we see the medical reports, we will say there are 70 cases per 1,000 of the population which are affected with dementia. Out of dementia, the 3/4 of the population have only two diseases, Alzheimer or the Parkinson's disease. So our research focuses on basically these two diseases of dementia, Alzheimer and the Parkinson's. So what is Alzheimer disease? It is a neurological disorder that causes memory loss and cognitive decline due to the death of various brain cells. It causes presence of intercellular beta amyloid plaques and intercellular twisted and insoluble fibers that is called tau tangles in the brain. So the main symptoms of the Alzheimer disease include memory loss, impairment to judgments, problem solving, recognizing faces or objects, difficulty in handwriting, speaking and speech, and changes in personality and behavior of the patient. However, in Parkinson's disease, uh, it is a neurological disorder which is also known as movement disorder that directly affects the nervous system. The main symptoms of Parkinson's disease include tremoring in the hands and voice, patient posture and facial expressions, obviously permanently changed, loss of sense of smell, and problem with the urination and the problem of constipation, etc. So one of the major contribution is that we have designed a model on the basis of deep learning for multi-class classification of Alzheimer disease. We have already discussed how we can use deep learning model. I will present a glimpse only of this my paper. So here what we have used, we have provided a framework which is called a multi-layer framework in order to identify three different classes of this Alzheimer disease. So we have used the concept of transfer learning also. We use transfer learning in the form of deep learning pre-trained model, that is LXNet, and in the further training we have used LSTM model, because the data set which we have used is the ADNI data set. This data set is of very limited size, so we have used here GAN. I have already discussed generative adversarial networks technique in order to synthetically increase the size of our data sets. And finally, we classify the stage that patient is on what stage of the Alzheimer disease. There are basically three stages: AD, MCI, and CN. So these are the various phases which we have: data collection, pre-processing, augmentation, feature extraction, then testing and performance. So for was the need of data pre-processing? So whenever we have multi classes, there is a need of there may be a problem of class imbalance. Like there may be more number of say cases of patients which are having from the one class only, or you can say there may be lesser number of patients with class 2 and class 3. In that case, we need to use the concept of oversampling and undersampling. So what undersampling and oversampling are doing? Undersampling simply entails eliminating instances from the majority class, whereas oversampling means copying instances from the minority class. Therefore, in our case, oversampling is applied to AD class, AD and CN classes, and undersampling we have applied to the MCI class. Okay, we have applied data augmentation to synthetically generate data with the help of GANs. So this is the basic description of the data set. So we can see that without GAN, this was the number of images, and with GAN, it was increased a lot. So this is the proposed basically framework. Earlier we are having MRI images. We converted these images to the .png format, which was required. Then certain resizing was also done because the deep learning model was able to handle that much size only. So then we provide normalization, sampling, and other things. So basically the purpose was to, first was the data collection, then pre-processing, then data augmentation. Once the data was augmented, it means now we are having the sufficient data which we can feed to our model for training and testing. So once the data is ready with us, then we can use the pre-trained model for feature extraction and further classification. And after that, the last stage was testing, and we computed the performance of the given model, and we evaluate the performance on the basis of various metrics like accuracy, sensitivity, specificity, etc., etc. In the second, we designed an integrated model for the multi-class classification. Here we use the Parkinson's disease. So what was the purpose here is the main concept was feature extractions. We use certain existing manual techniques as well as deep learning model technique. Then we combined features from manual techniques as well as the feature extraction technique autoencoder, which is basically used for by the deep learning model. Then because we are having a large number of features which we have extracted, then we used one technique which is called Baruta. So this Baruta technique would simply extract the very important features and remove the redundant and irrelevant features from our data set. So the here the main focus was the data set. हमने मतलब we refine the data set as per our requirement. So here we used one a new concept that was CapsNet, which is called the capsule network, which is the newly proposed network in the area of machine learning. So here again, we did the same things. This is the diagram of the proposed framework. Then we find out the classifications for the all the three classes: training, validation, testing, and so on. So these are the results. You can simply say in the third one, we have used the technique of ensemble learning, where we have used 5 deep learning base classifiers. And here the novelty lies in the term of ranking algorithms. Basically, when we use the concept of ensembling, say there are 5, we have used 5 different classifiers. It is not an easy task to decide which of the classifier has the more weight. So we have used 4 mathematical ranking algorithms in order to rank the base qualifiers. And accordingly, according the rank of the base classifier, we have assigned some weights to that. Accordingly, we have used ensembling. That is the main, you can say, novelty of this proposed multi-class algorithm for this. So we have used these 4 ranking algorithms for the ensembling, and these 5 are the base, deep learning, you can say pre-trained classifiers that have been proposed by the various researchers we have used, and accordingly we have ranked them. And obviously the results of the proposed model was very high in comparison to the other existing models. So that's all from my side about the machine learning and healthcare. So my other contributions are available on my Google Scholar as well as the ResearchGate. If you are willing, you can go through that. Thank you. Yes, sir.
Thank you so much, ma'am.
Yeah.
Any question, participants?
Very nice
Okay, ma'am.
presentation.
Yes, please go ahead.
Ma'am?
Yes.
Hello? Can you hear me?
Yeah, please.
Thank you, ma'am.
Welcome.
Sir, your voice is little slow.
I'm Dr. Vaithiyanathan. I'm from Puducherry, ma'am. Machine learning nowadays it will be a very emerging trend, ma'am. But the collection of the data is very difficult for training and trained data. So if particularly if I have any very small size only nowadays we may get it. So that makes giving accuracy of that.
Actually, your voice is not clear. Still, I'm trying to understand your question. I think you are talking about the data sets.
Yes, ma'am. Actually,
Yeah, your question is about the
the
data
data
set.
collection
Like,
of the data for healthcare is, ma'am. Yes, ma'am.
actually, what happens when we are working on in the field of healthcare, the data is very sensitive, and the hospitals or even the PGIs are not ready to share any data with the researchers. So what we are doing, like if I am working on in the area of Parkinson's disease and the Alzheimer disease, I have mentioned also for the Parkinson's, there is a society in USA with the name of Parkinson's Progression Markers Initiative. they are having a very large amount of data which they have collected themselves in their laboratories. So that data is not easily available, but we can request them for the research purpose and get the data. Then they authorize us for only 1 day or say 24 hours. During that, we can download the data from their server. Like this PPMI data, which I have used for the Parkinson's data set, the speed was very high. So we downloaded within 24 or 26 hours because we started downloading on the server and it took around 24 to 26 hours. However, this Alzheimer data set, which we have taken from ADNI, so again, it was available on request, official request we sent them, and there were certain like MOU kind of things also, which we signed that we will not use this data set for any other purpose and so on. So, but the problem with the ADNI data set, that was Alzheimer Disease Neuroimaging Initiative Society. Here the speed was very slow. It take around 2.5 days for the like downloading of the data, because the servers were very slow and the size was not very large. Therefore, for the Alzheimer disease data set, we have used the concept of synthetic data generation, and we use the GAN like technique for the generation of the data. The data sets are available, but usually they are available on request only. You need to like search through the various universities and other things. Otherwise, sometimes they are available on the GitHub. Also, various repositories are there. They provide on request. Yes, anything else you want to ask?
Thank you, ma'am. Very nice explanation. Oh, ma'am, actually, another question, ma'am. Hello?
Sorry, sir, your voice is not clear actually. I'm just trying to understand what you are asking.
Okay, ma'am. Sorry, ma'am. I'm in my campus. It was a little bit remote. My network is very poor, so that I may. Okay, ma'am. Thank you for your explanation.
Okay, sir.
I will put in chat box my question.
Okay, sir.
Okay. Thank you, ma'am. Thank you.
Ma'am, there is a question in chat box. Dr. P. Suganti is asking about some benchmark data set for dementia patients.
Yeah. There are many data sets which are available for the dementia disease. Actually, I am having a very good review paper on this dementia disease. And if possible, you can drop me a request on my ResearchGate. I'll share that paper. There are around 10 to 15 data sets which are available on request. I have mentioned all the data sets with their links also in that paper. I'll share that paper with you.
Good afternoon, ma'am. My question is, in today's generation, there is a boom in wearable devices. So, if we are using wearable devices for collecting real-time patient data for many types of disease and doing for disease management, does it have a privacy concern in managing those data by using wearable devices?
Definitely, privacy is always very important, because the patient may not be willing to share his or her data with the everyone. Only you say the data should be available on that say doctor's desk only, where you are collecting the data. But if the data is freely available, so that's why we use the concept of blockchain nowadays for the storage of the data. If you are collecting data yourself, like wearable devices, just like you are saying, so in that case, the first thing is the data collection. Once you have collected the data, so the main problem with that data is the pre-processing, because there will be a large number of outliers, say anomalies will be there. You have to first remove those anomalies, only then it can be used for further analysis. So uh, there are various data sets, pre-processed data sets are available, which are being used by the researchers. But obviously, whenever if you are collecting data for wearable devices also, they are being stored on some application, which may be a secured application. In that case, there may not be any problem of security and privacy. It depends how you are using that data, where you are collecting the data. It depends on the application also and the environment or the platform which you have designed for your healthcare services.
Okay, ma'am. Clear, ma'am. Thank you, ma'am.
Okay.
Okay, so ma'am, one more person is asking about the data sets. So it will be helpful, ma'am, if you post your mail ID in the chat box so people can connect with you directly.
I have not worked in the area of autisms and ADHD at present. So we have worked only in the field of dementias. My research
Okay.
group is presently working in the area of blockchain also. We have contributed 4 papers in SCI journals on this healthcare, machine learning, and blockchain technologies. So all these research papers are freely available on my ResearchGate and Google Scholar profile. If you have to make any request, you can drop just simply a request on my ResearchGate. I'll share my papers. Otherwise, also, if you want to discuss something, you can drop me a mail also. Anytime.
Okay, thank you so much, ma'am. So, here now I would like to express our sincere gratitude to ma'am for the enlightening talk on big data and its application in healthcare. So, ma'am, your insights into how big data is transforming patient care and improving operational efficiency have been truly inspiring. Thank you so much, ma'am. Your ability to simplify such a complex topic and present it with examples have given us deeper understanding. Thank you so much, ma'am.
Welcome, ma'am. Thank you, everyone.
Okay, so thank you so much.
Participants benefited
So,
from the talk, ma'am. Thank you so much.
Thank you, ma'am. Thanks for the invitation. Yeah.
Okay, ma'am. Okay. Thank you.
Okay. Bye. Bye, ma'am.
Bye, ma'am.
Can I leave the meeting?
Yeah, sure, ma'am. Sure.
Okay. Thank you, everyone. Thank you. Bye.
Let's wait for 5 minutes and then take a 5 minutes break, and then our next speaker will